On April 2nd, 2026, Google DeepMind released Gemma 4 open-weight AI models built from the same research as Gemini 3, and for the first time, licensed under Apache 2. The 31B dense model ranks number 3 globally among open models on the LM Arena leaderboard, competing with and beating models up to 20 times its own size. This is the most capable open model family Google has ever shipped. Gemma 4 comes in 4 models. E2B and E4B are the effective models, optimized for mobile and edge devices. The 26B Mixture of Experts and 31B Dense are workstation-class models. All 4 support images and audio. The 2 larger models add video. Context windows are 128,000 tokens for the E models, 256,000 for the larger 2. It is a family designed to cover every deployment environment from smartphone to data center. The E2B and E4B are a new class of on-device AI champion. E2B has 2.3 billion active parameters, but carries 5.1 billion of representational depth, thanks to per-layer embeddings. It achieves near-zero latency on modern Android phones, Raspberry Pi, and Jetson Nano. E4B scales to 4.5 billion active and 8 billion total, targeting flagship smartphones and single-board computers. Both include full image and audio support, no remote API needed. The 26B Mixture of Experts is the efficiency king of the family. It stores knowledge in 25.2 billion parameters, but activates only 3.8 billion per token, similar active compute to a 4 billion parameter model. It uses 128 small experts with 8 plus 1 shared expert active per token. This translates to high tokens per second throughput at top 6 open model quality. It runs unquantized on a single H180GB GPU and supports a 256,000 token context window with video understanding. The 31B Dense is the quality leader. All 30.7 billion parameters activate for every token. It ranks number 3 on LM Arena behind GLM5 and Kimi 2.5, both of which are dramatically larger models. AIME 2026 score, 89.2% without any tools. Codeforce's ELO, 2150, placing it in the Grandmaster tier of competitive programming, higher than 99% of human contestants. If you need the best open model available today and have a single H100, this is the one. Gemma 4's architecture introduces 3 key innovations. Per-layer embeddings inject a secondary embedding signal into every decoder layer, giving E-models double the representational depth at the same active compute. Alternating attention interleaves local sliding window layers with global full-context attention, making 256,000 token context practical on a single GPU. Dual row P uses standard rotary embeddings for local layers and proportional scaling for global layers, maintaining quality at extreme context lengths. Every Gemma 4 model ships with 2 encoders. The Vision encoder uses 2D position encoding with multidimensional row P and a configurable token budget from 70 to 1,120 tokens per image, letting you tune the accuracy-speed trade-off at inference time. The audio encoder is a USM-style conformer, the same architecture Google uses in production speech recognition, handling up to 30 seconds of audio. E2B can handle voice input, process camera images, and respond entirely on a smartphone with no remote calls. The reasoning benchmarks tell a clear story. MMLU Pro, 31B scores 85.2%, 26B scores 82.6%. GPQA Diamond, 84.3 and 82.3% respectively, strong doctoral-level science reasoning. But the most striking result is Big Bench Extra Hard. Gemma 3 scored 19.3%, Gemma 431B scores 74.4%. That is nearly a 4 times improvement on one of the hardest reasoning benchmarks in existence, specifically designed to resist memorization and shallow pattern matching. On coding, Live Code Bench v6, 80% for the 31B, 77.1% for the 26B MOE, and the number that really stands out, Codeforce's ELO of 2150, placing Gemma 4 in the Grandmaster tier. That is competitive programming at a level above roughly 99% of human coders. For software engineering tasks, agentic pipelines, and complex code generation, the 31B Dense is a genuinely elite open model. On vision and multimodal benchmarks, MMMU Pro Vision at 76.9% and Math Vision at 85.6%. Math vision is particularly notable. It tests the model's ability to read mathematical problems presented as images, parse diagrams and equations visually, and reason through them. 85.6% is a strong signal that Gemma 4's vision encoder is not just for image description. It understands visual structure mathematically. Gemma 4 ships with first-class agentic support baked into the base models. All four support native function calling compatible with OpenAI-style conventions, schema-constrained JSON output generation, and reliable system instruction following across multi-turn conversations. This means you can drop these models directly into LangChain, Llama Index, or CrewAI pipelines without fine-tuning. For on-device agentic apps on mobile, E2B and E4B bring this capability to smartphones for the first time. The license change is arguably the biggest news in this release. Previous Gemma models used a custom license with monthly active user caps, acceptable use restrictions, and commercial ambiguity that kept enterprise legal teams away. Apache 2 removes all of it. No MAU caps, no acceptable use restrictions, full commercial freedom, sub-licensing permitted, and an explicit patent grant. Google is betting on adoption over control. For the 100,000 plus community variants in the Gemmaverse, this is a retroactive gift. So who should use which model? E2B for always-on mobile AI and IoT, E4B for flagship smartphones and Raspberry Pi. The 26B MOE for high-throughput production workloads on a single GPU. The 31B dense for quality-critical applications, fine-tuning, and research. All four are Apache 2, all four are multimodal, all four are built from Gemini 3 research. Read the full article at ThinkSmart. Life/research/posts/Google Gemma 4 complete guide.